So, we continue on that quality aspect, right. Now, obviously, as we said in the beginning that we will be adhering to as much, but may not be possible all the time to adhere to the course mates outline which was given, right, because there are many like this quality which is a very important aspect on food. So, how could we minimize it? As much as information we can disseminate to you, that is much better for you. So, that is why I am still continuing on it. Maybe I do not know if I am not able to cover up today on that or in this class, then we may be asking for, right. So, let us go. What is that on the other part, aroma and flavor and taste, which we were saying, right. So, aroma is an odor and is often referred to as a smell and is sensed by the receptors in the nose. So, as you know, this is called olfactory region. Olfactory region, which we have this nasal and mouth cavity all put together. This is called olfactory region, where you have lot many sensors which can sense, because human being is the best creation of nature, right. They have so many things which yet to be copied or yet to be fabricated equivalent to that. But we know that in how many numbers of rather we can say you can definitely differentiate between mango aroma which is coming from mango, or maybe coconut oil which is having another aroma. Even from the distance you can differentiate them. So, right. So, it is that it is sensed by the receptors in the nose, and that is what is aroma. And taste or gustation, that may be the sense that may be the sensation of saltiness or sweetness or sourness or bitterness and umami of the food material, and that comes under the umbrella of the taste, right. We say this has this taste, right. Whereas, flavor is the sense of taste and smell both in combination, right. So, it both in combination, sense of taste and smell, that comes under the purview of flavor, right. So, if we say aroma, we also can differently say that yes, the flavor of that, but you will see in most of the cases we use both for both the purposes. When saying aroma, we can mean that flavor. When saying flavor, we can mean the aroma. That is the general connotation. So, aroma and flavor normally most of the people do not differentiate, but yes, the aroma is through the nasal part, and this flavor is combination of both taste, that is mouth organ, and the nasal part in combination, right. So, if we look the other, we said the other class, the texture. The texture is normally analyzed through a texture profile analysis, TPA, right. We said that UTM, universal testing machine. So, this universal testing machine is normally different in different bodies or different manufacturers are being made. But for our nowadays science has become so progressed that different companies are making for these texture analyzers, right. many companies are making typically for food texture analyzer, because other textures, like everybody has texture, even you go to metallurgy, they have the steel, iron, this, that, so many textures there. Rubber, you will get that texture. So textures are texture is one of vital word. So it depends where the application. In food, it is altogether a different umbrella, and normally we say texture in terms of texture profile analysis, and in that this force versus deformation curve, right, this force versus deformation curve, that gives us lot of input, lot of information, and utilizing that information we can define texture altogether useful for food material, right. So TPA or texture is a measurement of texture attributes by mimicking, we are mimicking the act of the chewing. This I said that we are chewing. So this chewing we are mimicking by the help of the instrument, and that is, and this information is utilized subsequently for different terminologies in terms of texture. The probe will interact with the food 2 times, right. I cannot show you that texture profile analyzer here, but the thing is that if this is the base, right, if this is the base and if this is a probe, and on that base if this is a food material kept on that, right. So this probe comes here and touches it, and from there it is pressed or taken out. So this is done twice, right. So 2 times that is being done, and then change of force and time, will be recorded, and from the force time curve texture attributes of this sample can be determined or calculated. So that probe texture analyzer which has come and given some force to the food material. So that will be automatically going to that information to normally to some computers, and in that computer there is also nowadays those softwares are available which will analyze that data and give you the result in terms of your texture analysis, in terms of texture profile analysis, right. And typically a curve looks like that. Texture profile analyzer curve looks typically like this, right. And this is through an Instron TPA. So since Instron is again one universal testing machine, Instron is one instrument or one company which makes like that. There are many, but principle is, all the principles are same. Maybe their softwares could be different, but by principle they are like that. So and there also, as we texture bending and many others do come in that, but we are not concerned about that much, because we don't need much about the bending forces, etc. But we would like to know how much, like you have taken a peanut, right, you have taken a peanut in your mouth. Now you have to put pressure through your teeth, right. How much teeth pressure is given, that you are mimicking through this TPA or texture profile analysis, right. So if you look at this, you see that first, this is the first point when it is at the time 0, right, at the time 0, here this your thing has come, right? And then it is so sensitive, you see I have put my hand here and some color has come here, okay. It is very sensitive. So, from there this pressure is going up, right, and then after this first deformation this has come out, right, and this is called the first bite, or it is written as the fracturability, by which it has become fractured, right. Then it has come to this part, this is called the, again this is the first bite, or this tells about the hardness, right, hardness of the material, that can be like that. Then it comes back to 0 and then it pulls. This is a reverse force you are applying. Here you are, the direction of force which you are applying here, it is the reverse, right. And then following this, this again goes for the second bite and comes like that, right. Now, these distances, these areas like these, these areas, these distances, all are contributing to the development of different parameters on textures, right. So, basically TPA looks like that. We get area 1, area 2 and area 3, right, and we get two peaks, here one, here another, and we get another small peak here, and that is called fracturability, right. The moment when the fracture comes in that typical product, right, and that is the fracturability. How much hard it is called in terms of hardness, how much hard it is, right, how much pressure you have to put, that is the hardness. Then how much gumminess, chewiness they are there. So, those things will be according to the either distance of this, distance 1, distance 2, or area under A1, A2 and A3. So, that we will discuss, right. So, if we look at, so among the attributes that can be determined by this TPA are, first is the fracturability, right, which we just told. The first is the fracturability. Now, fracturability we mean that this is that fracturability. This we mean that the force needed to produce the first significant fracture during the first bite, right. The force which is required to make the significant fracture in the product during the first bite, that is the fracturability, right. So, quantity you are able to quantify, right, you are now able to quantify. Then hardness. Hardness is the largest force produced during the first bite. So, largest force which is required during the first bite can be said as the hardness of the material, right. The more harder, the more this will go, right, and then fall. If it is less hard, it will fall like that. So, more harder, this will be more, this height and or this height will be accordingly, right. So, more harder means more force you are required to put. Then cohesiveness. Cohesiveness is nothing but the ratio of area under the positive curve between the first and second bite, that is area under 2 by area under 1. If you remember that we had said, okay, we can go back, we had said. So, actually this in the earlier class I said that this is a very recent instrument by which we can write, show you everything. So, sometimes yes, this thing being we are not so familiar in everyday classes, So, maybe sometimes it may, however, it does not matter. So, this is the TPA. So, this was area under curve, this was area under this curve area 1, right. This was area under curve 2, say during the first bite, during the second bite, right. So, this area A1 and A2, this ratio, that will tell us, as you said, the parameter which we just said that will be okay. So, this was cohesiveness, that ratio of area A2 by area A1, right. I again go back because it is becoming difficult, that these three area we remember A1 this, A2 this and A3 this, right. So, this these are the two positive areas, that is why in definition we have said that the positive area, the ratio of area under the positive curve between the first and second bite, that is area A2 by A1 is cohesiveness. Others we can say adhesiveness, right. Adhesiveness, work needed to pull out the probe from the sample after the first bite. So, you have made this, right. So, the whole material is between your teeth, two teeth, right. So, it is stuck like that. So, after that when you are releasing, right, how much force you are required to release. So, that when you are releasing it, how much force you are releasing, that will dictate the adhesiveness, how adhesive it is, right. So, that is that work needed to pull out the probe from the sample after the first bite, that is by area 3. You remember? So, this was that the lower part, right, this lower part area 3 was. Okay. So, this area will tell you that how adhesive it is. Then comes springiness, right. Springiness, this is ratio of by mistake it has come in. So, ratio of the biting distance of the second bite with the first bite, the distance 2 by distance 1. And again I go back to that if possible, that this is the first bite. So, this distance, again this distance, this was the first bite, this distance 1, and this is the second bite, because it started from here for second bite, right. So, these the two distances will dictate, and this was area 3 which were used for cohesiveness, right. So, we have also seen that how much this distance, once we know that, then we can say all the parameters, right. So, adhesiveness, cohesiveness is done, then springiness. Springiness is that the ratio of the biting distance of the second bite to that of the first bite, right. So, that is distance 2 by distance 1, right. Distance 2 was this with the second bite, and distance 1 was this for the first bite, right. This was that. So, this was distance 1 and this was distance 2, right. So, d2 by d1 is the springiness. Then gumminess. Gumminess is the product of hardness and cohesiveness. Gumminess is the product of hardness, cohesiveness, and then chewiness. Chewiness is also a product of already measured, that is gumminess into springiness is the chewiness, right. Gumminess into springiness is the chewiness. So, once we know all of them, then we can say that we are able to tell the texture properly, right. So, again I repeat, one is fracturability, then hardness, then cohesiveness, and then adhesiveness or springiness, gumminess and chewiness. All these we obtain from the texture profile analysis or TPA. So, you see, you are able to measure absolutely or calculate absolutely for a definite food material what should be the quality parameters, either before or after processing, as and when you require. Obviously, this will be, you will be implementing it whenever you are requiring. So, you have so many parameters in hand to tell the quality. Then it comes really, what about the product quality in terms of consumer point of view or in terms of retailer point of view. Consumer wants that fresh, tasty, variety and convenient food. So, if you ask any consumer, he will say, I want quality in terms of freshness of the material or in terms of the taste of the material, variety of the material or convenience, how convenient it is. If you say that I give you a product like this and now you do X, Y, Z, etc. steps to make it edible for you, obviously the consumer will say no, may or may not be, right. But if you say I give you this product, you do not have to do anything, you take home and open your covering, that is the packaging material, and directly consuming, you will like it the most, right. So, from the point of view of the consumer, his liking in terms of quality will be that it should be as fresh as possible, it should be as tasty as possible, or you should have various type of variety, and also it should be convenient for the consumer. That is the consumer point of view quality we can say. But the people who will be called retailers selling it, will be selling it, right, they will have also different quality parameters, like they will say availability, obviously a product which is very good but not available, so that they do not want, because they have to sell it. People will ask, consumer will ask and tell them. So, there in terms of quality, you will see it in the term of availability, then accessibility, then presentability, or then prolonged shelf life, how much shelf life it has, and also the conformance, that how good, how bad it is, and that confirmation they want, right. That is from the point of view of the retailer. Manufacturer will tell, okay, we will meet the requirement of the whatever consumer wants, or we will exceed the expectation of the consumer and the retailer. That is what the producer or the manufacturer will target and tell. To them, quality is that, right. But to the scientist, as we have defined, is the quality parameters, right. Then safety. How we can say product safety? Consumer will tell the preservation without compromising quality, if can be done, is the safest food. In terms of quality, if I don't have to forego quality, if I don't have to compromise with quality, and if the life can be extended to any desirable time, then my safety is that, my safe food is that. But retailer will say, retailer means who is selling, that if it is sustainable preservation over an expanded distribution network, right? Obviously, product could be manufactured at a point, so where product could be manufactured at a point, say here, and then it will go from there to here, then there, like that. So this fellow will say, to me, my quality is, it should be sustainable in terms of preservation over an extended distribution network, right? And manufacturer will say, yes, we will try to exceed the expectation of the both consumer and the retailer, and that can be the safest food product, right? Then we come, of course, again this is another thing. Today we have come almost to the end of the class, very limited time is available. So, before going into that emerging technology, I feel let us recapitulate a little, then going into the new topic, that is emerging technology, which will take at least one period class. So, if we look at then, because again as I said that this is a very important material which we have dealt with today, that this texture profile analysis or quality, right? Quality parameter. This quality should have some parameters by the either consumer or by the retailer or by the producer. So, in terms of them, there should be some quality parameters, but when as a scientist you are asked to judge a food material in terms of its quality, then you should have defined parameters. We said that the shape, size and color of this, then flavor, aroma, they are, then we also said texture, then we also said maybe viscosity if it is a liquid or semi-liquid food, and some other parameters like how long it can be extended, then how the packaging is coming in, right? Because packaging is indirect. Why? Because packaging may help to extend the life directly or indirectly. So, directly in the sense that if a product is not in contact with the environment outside, that will save the product inside the packaging material to be contaminated, right. So, packaging plays an important role there. Like that, whatever we have discussed today, so hopefully you go through them very seriously and keep the quality term for the food products in mind. Okay? Thank you.